Yo, 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 yo. Welcome back. So, how did it go? I hope you guys, play around with it, have fun. And I'm gonna show. Well, I'm not gonna show. I'm gonna say show. I'm gonna share with you how I would do it. All right. So we are going to differentiate y equal to 5 to the power of x with implicit derivative, right? Because explicit is I don't know, not that obvious, I don't think. Even though it is given to you in explicit form, but the irony here is that you can't use the explicit form so you can't use, the irony is here is you can't use explicit differentiation to solve this, even though it is given in an explicit form. Alright, so let's start. Now, the biggest question, or the biggest trouble, is this particular x over here. Right? It's to the power of x. The x is not with the 5. It's actually 5 to the power of x. Alright? So the first thing I would think about is, how do I make that thing comes down? How do I pull that little bugger down? Alright? So I would think about ln or log e. Alright? Or any log base. Or we just choose e because we know the derivative of that. Okay, so let's go ln both sides. Yeah? Now, with the index law, we know that we can bring the power to the front. Right, like that. Right? Now, this is where we differentiate both sides with respect to x. Right. Now let's do the easy one first, which is the right hand side. Now, when you look at this x ln 5, remember ln 5 or log e5 is a number. It is a constant. So this is the same as 5x or 6x or 7x. This is a number with x. Right? Because ln 5 is a number. So what do you do when you're differentiating something like this? What do you get? You get 5, you get 6, you get 7, right? Or you get just a. So in this case, the ln 5 is the number. So differentiating that, the right hand side will just give us ln 5. Right? Makes sense? Alright? Now let's go to the left hand side, where it's a bit tricky. Now, remember, like we said before, y is a function of x. Alright, y is a function of x. So you can treat this as just a big bracket, right? And differentiating that with respect to x. Now, how do you normally differentiate ln something? Or ln x. Let's put it this way. How do you normally differentiate ln x? Well, we know that if y equal to ln x, y dash is equal to 1 over x. Well, multiplied by the derivative of that particular thing, but in this case it's 1. Alright, so same thing, right? So we know that y is a function of x. So if you're differentiating ln y, you are just literally doing it 1 over y. Yeah, just like that. Yeah, just like what we did here. You just differentiate this. It's 1 over whatever that is. Whatever inside the bracket. In this case, what's inside of the ln bracket is y. So it's just 1 over y. And then what do you do next? So what you do next is you multiply by the derivative inside the bracket. And what is the derivative inside the bracket with respect to x? You will get dy dx. Right? Because whatever inside the bracket is y. So if you're differentiating y with respect to x, you get dy dx. Yeah? So the first dx, just to make it clear, the first dx has been used to derive ln, which give you 1 over whatever the bracket is. So in this case, 1 over y. And we always have to multiply by, because this is a chain rule, this is like a chain rule. So we always have to multiply by the derivative inside the bracket next, right? So which will be dy dx. And that is what we want. Okay, so that's equal to ln 5. Right? And now we know that dy dx is equal to ln 5 multiplied by y. And remember, what is y? Y is just 5 to the power of x. Yeah, y is just 5 to the power of x. So dy dx, so therefore we can finally finish it, is just ln 5 multiplied by 5 to the power of x. Yeah, simple. Very good. If you come down to this step, you got it. We have just proved that the derivative of a to the power of x is ln a multiplied by a to the power of x. We got that. Cool. Now, remember when I said that I don't like this rule. I do not like this rule because I think it is imperfect. Because so many people will just look at the rule, okay, and literally copy it without doing the calculation, without going through the implicit differentiation. And some people will say, why should I go through? Because we just proved it works. Well, if you think about it, if you follow this rule, great. Okay, let's just put it this way. If I follow that particular rule, all right, so let's write down the rule again. So it's y equal to a to the power of x. Y dash is equal to ln a multiplied by ax, right? So what happened if I give you this particular number? So what happened if we are trying to find, let's say 7x squared? All right, following that particular rule, do you get this? Do you? No, you don't. All right, let's do it implicitly. Let's do it with implicit differentiation. We already did it once. It should be easy. So let's write down the equation here. We go ln both sides. Right? Bring the power to the front with the index law. And then derive both sides with respect to x. Right. So let's do the right hand side. What do you get? Remember, this ln7 is just a number. It's just any number. So you will get what? You will actually get 2x, which is the derivative of the x squared, right? 2x. And that now ln7 just tag along, right? And that's it. That's the derivative. Yeah? Or you can write it as 2 ln7 x. You know, make it look nicer. And whatever we got here is the same. It's always going to be 1 over y because the derivative of ln is 1 over whatever inside the bracket is. And then multiply by the derivative inside the bracket with respect to x, which is dy dx, exactly what we wanted. So we can move the y of move the 1 over y to the other side by multiplying by y. So therefore the actual answer should be 2 multiplied by ln7 multiplied by x multiplied by whatever we started with, which is 7x squared. 7 to the power of x squared. Boom! Boom! There! That should be the answer. And if you just blindly following the rule, you will never get there, right? Because the rule is not wrong, but the rule has an assumption. Yeah, you guys should be familiar with this word. You would have been doing that in your assignments. The rule have an assumption. It's assuming the x is always to the power of 1. And this would make sense. And this rule would stay the truth because there's just 1 here, which is the derivative of that. They just didn't bother showing it. It's just that. They didn't bother showing it because it's 1 multiplied by 1. It doesn't really change any values. So properly, if you want to do it properly, the rule, right? The rule properly should be, it shouldn't be this. Properly, the rule should be, right, that. And then y dash will be ln a multiplied by x, multiplied by, it should be, what do you call it? The derivative of that. Sorry, just don't move the end there. This makes it confuse myself. That. That should be the actual formula. More better to describe any scenarios. Yeah? Don't you think so? And you will only realize this if you do it the implicit, if you understand implicit differentiation and did it that way. You will realize that we are missing, that particular equation is missing the dx over dx, the derivative of x with respect to x. Whew. Now, hopefully you understand the last 2 videos which I talk about, this video and the last video which I talked about implicit differentiation. And like I said, it will help you understand a much more variety of questions. Yeah, you can tackle much more questions easily, right? And you can do better. Look, like I said, I don't know what to help you in the exam. All right, one of my students always asks me this. Every time when I'm trying to share something with her, yeah, it's a her. She always say, "Would this help in my exam?" No, I'm assuming that I'm not picking on her or anything, but I'm assuming most of the people will do that to their tutors as well. But guys, like me and other tutors, I'm pretty sure they all are, we are just trying to help you to get better, right? Once you get better, your result will improve. You will be able to do more in the exam if you know more yourself. And wouldn't that help your grade? Of course that would. But if you're asking me, does it have any direct relation with your grade, with your result, or would it be in your test? I don't know. But it will help you. And you yourself is the single determining factor, the most important one actually, of your actual result. Because you're doing the test, right? You're doing the test with all your knowledge, and if you got more knowledge than the others, wouldn't you get a better result, right? Okay, before I lose myself there, so that's it. This is this video is just to show you that you can use how to differentiate y equal to 5 to the power of x with implicit differentiation, and it works, right? And it works. So hopefully you find this useful, and we will do a tricky question, which is the modeling next shortly, or in the upcoming videos, which will require you to understand the implicit differentiation. And who knows, those questions might be an A-level question in your year 12 exams. Who knows? Would you want to know how to do it? Would you want to know how to approach it? Stay tuned.